Hey everyone, Mrs. Garcia here. Today we're looking at notes over adding, subtracting, multiplying, and dividing fractions. And actually first we're going to talk about multiplying and dividing. So in order to multiply or divide fractions, you do not need a common denominator. So when you're multiplying, you will simplify first if possible, top to bottom or diagonally only. Then you'll multiply numerators across the top. Then you'll multiply denominators or across the bottom. When you're dividing, first you will keep it, change it, flip it, or KCF. You'll do that first. And then you'll simplify if possible, and then you'll multiply like we did before. Okay, so first we're going to start with number 1, multiplying. That little dot there means multiplication. So this is 2/5 times 9/5. So let's simplify first if possible, top to bottom or diagonally. So top to bottom, does this fraction simplify? No. Top to bottom, does this fraction simplify? No. Diagonally, do these two numbers simplify? No. What about these two? No. So I've checked all top to bottoms, all diagonals. Nothing simplifies, so therefore, we're going to multiply the numerators or across the top. So 2 times 9, which is 18. And then we're going to multiply denominators or across the bottom. 5 times 5, which is 25. And if you've simplified in the beginning, you shouldn't have to simplify in the end. So that should be your final answer. All right, so on number 2, we've got another multiply problem. So we've got 55 over 18 times 12 over 25. Okay, so 55 over 18, remember we're going to simplify first if possible, top to bottom or diagonally only. 55 over 18 does not simplify. The only thing that goes into 55 is 5 and 11, okay, other than 1 in itself. And so those numbers don't go into 18, so nothing simplifies here. 12 over 25, same, doesn't simplify. Diagonally, though, this 55 and this 25 can simplify because what goes into both of those numbers? The highest number that goes into both of those numbers. And that's 5. So 5 goes into 55 11 times, while 5 goes into 25 5 times. And then similarly, diagonally here, we can simplify the 12 and the 18. You're probably thinking, oh, they're both even. Well, yes, they're both even, and they're even both divisible by 3, but go as high as you can go, and that value is going to be 6. So if I divide 12 by 6, that's going to be 2. And if I divide 18 by 6, that's going to be 3. So once I've simplified as much as possible, I'm still going to double check. 2 over 5 doesn't simplify, 11 over 3, the diagonals don't go any further. Once I'm done simplifying, then again, you'll multiply those numerators, 11 times 2, which is 22. And then you'll multiply those denominators, 3 times 5, which is 15. And so, like I said, if you simplified in the beginning, you don't need to worry about simplifying in the end, so that answer should be all the way finished. Okay, next problem, 3. 5/9 times 36. So remember when you're dealing with an integer, that integer, or a whole number, that's what an integer is, can always be written as over 1. So we've got this 36 over 1 here. So again, remember, you'll simplify first, top to bottom, nothing simplifies, and then diagonally if possible. And here diagonally we can't simplify, but here we can. Both of these values are divisible by 9 if we go as high as we can go. So this will be 4, because 36 divided by 9 is 4, and 9 divided by 9 is simply 1. So then again, once I've simplified all I can, and I have, then I multiply my numerators, 5 times 4, which is 20, and then I multiply my denominators, 1 times 1, which is 1, and of course that 20 over 1, the 1 is not necessary, we'll just leave it, final answer is 20. Okay, number 4, so now we get to the division. So remember for division, we've got to keep it, change it, flip it, or KCF first. So what does that mean? That means keep this fraction, I've got to kind of push this up, sorry. Keep this fraction, change that division to multiplication, and then flip this guy. So this becomes 9/10. And then it really is just simply what we've been doing before. It's a multiplication problem. So now again, I'm going to see if I can simplify top to bottom, and I can't. Can I simplify diagonally? Here, no. Here, I at least can divide by 2. Let's see if that's it. So if I divide by 2, I'll get 24 here, and I'll get 5 here. Let's see if we can go further. Can 24 and 5 simplify any further? No, so that's it. Okay, so then I'm going to, of course, multiply my numerators, 24 times 9. So I'm going to come off to the side here. Hopefully you can see 24 times 9. And I like to do it this way. For me, it's easier to see 20 times 9 and then add it to 4 times 9. What's 20 times 9? It's 180. And then what's 4 times 9? It's 36. 180 plus 36 is 216. So 216, and I usually do that in my head, but I want to show you what I do in my head so you can do it in your head. So that's 216, and then 5 times 5 is 25. And like I said, if we've simplified here and we have, then this answer shouldn't simplify further. It should be your final answer. Okay, moving right along, number 5. So again, division. So we're going to do our keep it, change it, flip it first. You've got to do that first. You cannot simplify first. Please, please, please don't simplify first. You've got to keep it, change it, flip it first. And then you can go to town simplifying. So here, this 3 over 3, when you divide both values by 3, you get 1 and 1. And then nothing else can simplify. So 1 times 13 is 13, and 7 times 1 is 7. That won't simplify further, so you're done. Next problem. Remember that integer can be written as 6 over 1. So we're going to keep it, 6 over 1, change it, and then flip it, 5 over 18. And then we're going to simplify. So the only place I see we can simplify is here. Both of those numbers are divisible by 6. So this will become 1 because 6 divided by 6 is 1. And 18 divided by 6 is 3. And then multiply my numerators. 1 times 5 is 5. And then denominators, 1 times 3 is 3. So 5/3. Okay, last problem on this page, problem number 7. So again, I have this integer value of 9 here. So I'm going to put 9 over 1. And I'm going to keep it, change it, flip it. Okay, and then simplify. So both of these 9s can turn to 1 because they're both divisible by 9. Obviously, 9 divided by 9 is 1. 9 divided by 9 is 1. And then multiply my numerators. 1 times 1 is 1. And then 10 times 1 is 10. Now, unlike this problem where I could get rid of that 1 that was a placeholder, here I can't get rid of that 1 because that would change this problem. 1/10 is not the same thing as 10, so I can't get rid of the 1. It needs to stay on top as a placeholder. Here, 20 over 1 is the same as 20. Okay, but here I need to keep that 1 on top. All right, so let's get to the addition and subtraction, which is a little bit more difficult, but I know you can handle it. So in order to add and subtract fractions, you must have a common denominator. So that's the hardest part, I think. Then from there, it's pretty easy because then all you have to do is add or subtract the numerators. So across the top, kind of like multiplication, but you keep the denominators the same. Okay, and then in the end, you will have to simplify if possible for these type. Okay, so let's look at number 8. So obviously the first thing I do is I look at the denominators and I ask myself, are they common? Do I have a common denominator? 30 and 6 are not common. So then I say, okay, I have to get a common denominator, so I look at the smaller of the two numbers. 6 is the smaller of these two numbers, 30 and 6. Then I ask myself, is there some number I can multiply 6 by to get 30? And the answer is yes, I have an integer value, a whole number that I can multiply 6 by to get 30, and that value is 5. So I can't just multiply the denominator by 5. That would be illegal. That would be illegal in math. So I need to multiply by 5 over 5 because 5 over 5 is the same as 1. 5 over 5 simplifies to 1. And think about it, y'all. If I take any number, say like 37, if I take 37 and I times by 1, what is that answer still? It's still 37. So technically I'm not changing the value here, I'm just changing the way it looks. So it's always legal in math to multiply by 1, and 5 over 5 is the same thing as 1. Okay, so I didn't need to do anything to this fraction because that denominator, we're just keeping it. So that drags down 7 over 30 plus, and remember from our multiply part of our video, numerators 1 times 5, and then denominators 6 times 5. So then I have that common denominator. So then I can add or subtract the numerators across the top and keep the denominator the same. So let's do that. 7 plus 5 is 12. And then I keep my denominator the same, 30. And then of course I simplify if possible. So is 12 over 30 able to be simplified? The answer is yes. Both of these values are divisible by 6. Okay, and that's as high as I think I can go, but let's double check it. So divide 12 by 6 and I get 2. Divide 30 by 6 and I get 5. So 2/5 is our final answer, and yes, that's as far as you can go. Okay, so that was number 8. Let's move on to number 9. So in number 9 we have an integer again. Okay, this 2 can be written as 2 over 1. And these are my fave because if you look at the denominators, obviously they don't match, but if I look at the smaller of the two, which is 1, I can easily see that I can multiply 1 by 8 to get this denominator of 8. So what I'm going to do here, remember, in order to keep this very legal, a legal transaction here, I'm going to multiply by 8 over 8, okay, because that's like multiplying by 1. So of course, like before, that first fraction stays the same, 5/8, drag down the minus, because this is a subtraction problem now. And then I worry about numerator times numerator, so 16, 2 times 8 is 16, and then denominator times denominator, which would give me 8. So now I do have that desired common denominator, yay, and I do 5/8 minus 16/8. And remember, I just subtract or add, in this case we're subtracting, across the top are my numerators, so 5 minus 16 is negative 11, and I keep my denominators the same. And I always need to check, does this simplify whenever I'm doing addition and subtraction? The answer in this case is no, it doesn't simplify further, so we are good to go. All right, just 2 more, you're bearing with me. All right, so number 10, 3/10 minus 7/8. This one's a bit harder, so I look at my denominators, and they're obviously not common, they're not the same. And then I look at the lower of the two like I've been doing, okay, that's 8. And I ask myself, is there some integer or whole number, integer value that I can multiply 8 by to get 10? The answer is no, there's not a whole number I can multiply 8 by to get 10. So then I have to go about this a different way, okay? What I do is I take, this is the easiest way for me, I take that number and I start listing its multiples. So 8. 16. Do you see what I'm doing? So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. And here's why I'm going to stop here. I stop when I get to a number that this number goes into it. Do you see what I'm saying? So like here I stopped at 40 because 10 goes into 40. Okay, so that is our common denominator then. Okay, so 40 will be our common denominator, so what does that mean? That means I need to multiply both fractions. Now leave that minus sign alone, that's the minus sign. He's just gonna nicely drag down in between, leave him alone. Okay, so how do I get that common denominator of 40? Well, what do I need to multiply 8 by to get 40? The answer is 5, so I'm gonna multiply by 5 over 5 to keep this a legal transaction. And then on this side, what do I need to multiply 10 by to get 40? And the answer is 4, but to keep this a legal transaction, I'm going to multiply by 4 over 4. So this would be 4 times 3, which is 12, over 4 times 10, which is 40. Drug down the minus, then 7 times 5 is 35, and 8 times 5 is 40. So now I have that desired common denominator. So then I subtract across the top, 12 minus 35 is negative 23 over that common denominator of 40. And can I simplify further? The answer is no, I cannot. There's not one number other than 1 that divides evenly into both of those values. Okay, so last problem here. Okay, so again, when I'm subtracting like I am here, I look at those denominators and I say, do they match? The answer is no. And then I look at the smaller of the two and ask myself, is there an integer value that I can multiply 9 by to get 12? No, there's not. I can't. 9 times 1 is 9. 9 times 2 is 18. That's already too big. I don't have a whole number value I can multiply to get 12. So then, like I said, I list my multiples of that smaller number. So 9, 18, 27, 36. Why have I stopped at 36? Well, I've stopped at 36 because 12 can divide into 36. So 36 will be my common denominator. That means, again, that's a minus sign. Leave him alone. He's going to drag down. Okay, don't put him in the parentheses. That means I'm going to multiply this by 4 over 4 to give me that common denominator of 36. And then I'm going to multiply this guy. Now, that negative does belong to this fraction, so you do put it in the parentheses. I need to multiply this by 3 over 3 to give me that denominator of 36. So 3 times negative 7 is negative 21, over 3 times 12 is 36. Drug down the minus sign, 4 times 4 is 16, and 9 times 4 is 36. So now I have that common denominator of 36, so I keep the denominator. What's negative 21 minus 16? So that's going to give me negative 37. And this problem does not simplify further. Okay, there's not one value other than 1 that divides evenly into both of these values, so then we're done.